Hello student, this video lecture is prepared for particular technology subject and I will discuss the unit number 6, that is mixing. In last lecture we have already discussed what is meant by mixing, homogeneous and heterogeneous mixtures. Then I had discussed importance of mixing and agitation, mixing of liquid with liquid. And then we will discuss different types of impeller. First one is the propeller. So at the end of lecture, I had discussed propeller. So the propeller is generally having 3 blades. So if we look at the figure of the propeller, so this propeller is having 3 blades and it is rotated at a high speed. The speed of the propeller is in between 400 to 800 rpm, that means revolution per minute. And here if we look at this figure, this is the actually photograph of the propeller. So it is having 3 blades and it is mounted or insert in the tank in this way. So that means sometimes it is called a off center. So this is called off center. That means you have to introduce the propeller like shown in figure. So this is called a off center. That means you don't have to insert the propeller at the center of the tank because there is a vortex formation. So that part I will discuss in next slides. So here the propeller may be inserted in the tank from the side. So this is side entering propeller. So instead of off center, we can insert the propeller from the any side of the vessel. And this figure shows the flow pattern of the propeller. So propeller drive the liquid straight down. So this liquid is drive down to the bottom of the vessel, and at the bottom of the vessel this liquid stream spread radially, that means along with the radius in all directions, so like this, and then the liquid flow upward to the wall, so like this, and finally it returned to the suction of the impeller. So this is called a suction of the impeller. So this point. So in this way the flow pattern is generated. So first the liquid is drive at the bottom of the vessel, then it spread radially along the wall, and then finally it returned to the suction of the impeller. So in this way the flow pattern is developed when we are using the propeller in any vessel. So this type of agitators, or it is called a propeller, it is used for suspending the heavy particles. That means if you are mixing a solid material in a liquid, at that time you can use this type of the impeller. Next one is the turbine impellers. So there are different types of turbine impellers. So this is the open straight blade. So this is the actually top view, this is the side view. Then blade disc or flat disc blade. So this is actually top view. Then vertical curve blade. Then shrouded curve blade with the diffuser ring. Shrouded means there is a cover. This cover is provided along this blade of the impeller. Okay. So this is called a shrouded. So these are the actual photos of some of the turbines. Then there are again additional types, that is pitched blade turbine, curved blade turbines. And disc flat blade turbine. So here these are the components of the turbine. So here there is a shaft. The shaft is connected with the hub. So this part is called a hub, and this part is called a disc, impeller disc, and these are the blades. So these are the blades, and this is the disc. This is the hub, and here the shaft is connected. So this is the construction of the impeller. So generally the diameter of the impeller is kept 1/3 and 1/6 of the vessel diameter. And the blade length, that means this length, is provided 1/4 of the impeller diameter. So what is the diameter is provided? You have to just 1/4 of that value you have to taken as a blade length. And the curve blade, that means the blade which is having curves like this. So these types of a blade is having angle 30 to 60 degree. And the speed of these impellers is 50 to 250 revolution per minute. And turbines are used for different liquids which is having the viscosities up to 10 to the power 4 centipoise. So centipoise is nothing but it is the unit of the viscosity. So how the turbine flow pattern is obtained? That means when the turbine is inserted in the vessel, what is the flow pattern? So here this is the flow pattern. So when you insert the turbine in the vessel here, the impeller drive the liquid radially, that means in this direction, against the wall. So this is the wall, and the liquid stream is divided into two portions. So this liquid stream is divided into two portions. One portion flow downward direction, so here, and another portion is goes upward direction, so like this. So here this portion is goes upward direction, and again finally it return to the suction of the impeller, so like this. So liquid stream is divided into two streams. One is going in this direction and another is going in this direction, and again finally both streams are returned to the center of the impeller. So this is the flow pattern developed in a agitator. So generally the turbines develop the radial current. Radial means along the radius. Okay. Then next agitators is known as the paddles. So paddles is nothing but these are the having 2 or 4 flat blades instead of curve. There are flat blades, and generally these paddles are vertical. Means like in this direction. I will show the figure, and it is extended close to the vessel. That means here these turbines are having small diameter, but in case of paddles the diameter of that paddles is extended up to the wall, and it is having speed 20 to 150 rpm, and the diameter total length of that impellers are having 50 to 80% of the inside diameter of the vessel. Okay, and these circulation of the paddles are poor. That means circulation is not sufficient. So there are different types, that is known as the, sometimes it is called anchor. So if we look at this figure, so this is called a anchor. This is flat paddle, gate, and this is the combination of anchor and gate. So this is the combination of anchor and gate. So this is nothing but the paddles. So if we look at the actual photograph of the paddles, it will look like this. Okay. So this is the example of gate. Okay. So this type of agitators are also used just for the only mixing of the components, maybe liquid, solid liquid, or sometimes it is used for the highly viscous liquids in chemical reaction engineering also. These types of paddles are used. Then there is another concept known as the vortex. So what is meant by vortex? So if the low viscosity liquid is stirred, that means it is agitated in an unbaffled tank. So that means the baffles are not used, and that agitator is centrally mounted. That means at the center of that vessel it is mounted. So the lighter fluid, usually air, is to be drawn in the form of vortex at the surface of the liquid, and this process is called a vortex. Okay, and vortex reduce the degree of agitation or mixing. So I will show the actual figure of the vortex. So this is the vortex formation. So if we take that impeller and mount it at the center, so this type of a flow pattern is observed in that tank. So that is called a vortex, or you can see at this figure also 6.11. So it is a high speed impeller. So the air is drawn from this center of this impeller. So this is called a vortex. So if the vortex is formed in the agitated vessel, it will reduce the degree of the agitation. Then how the vortex formation is minimized? So there are three methods: off center mounting of the impeller, use of baffles, and use of diffuser ring with the turbines. So first I will discuss this first method, that is off center method. So what is meant by off center? You have to just mount the agitator in the side of the tank. So instead of center, you have to just add the agitator at the side of the vessel. So this is called a off center mounting. Okay. Or sometimes you can enter this agitator from the side of the vessel. So like this. Okay. So these are the two, this is the one of the method to prevent the vortex formation. So vortex is nothing but it is an undesirable process. So remaining part we will discuss in next lecture. So today's lecture I had discussed how the propellers are working, what is the flow pattern is developed by propeller. Then turbines, what are the different types of turbines. Then what is the flow pattern developed by these turbines. And at the end of lectures, we had discussed paddles. So these are the figures of paddle. And before end of the lecture, I had discussed the concept of vortex and how this vortex is minimized. So remaining part we will discuss in the next lecture.